Hello and welcome to the Data Engineering Podcast, the show about modern data management. Have you ever woken up to a crisis because a number on a dashboard is broken and no one knows why, or sent out frustrating Slack messages trying to find the right dataset, or tried to understand what a column name means? Our friends at Atlan started out as a data team themselves and faced all this collaboration chaos. They started building Atlan as an internal tool for themselves. Atlan is a collaborative workspace for data-driven teams like GitHub for engineering or Figma for design teams. By acting as a virtual hub for data assets ranging from tables and dashboards to SQL snippets and code, Atlan enables teams to create a single source of truth for all of their data assets and collaborate across the modern data stack through deep integrations with tools like Snowflake, Slack, Looker, and more. Go to dataengineeringpodcast.com/Atlan today, that's ATLAN, and sign up for a free trial. If you're a Data Engineering Podcast listener, you get credits worth $3,000 on an annual subscription. When you're ready to build your next pipeline and want to test out the projects you hear about on the show, you'll need somewhere to deploy it, so check out our friends over at Linode. With their managed Kubernetes platform, it's now even easier to deploy and scale your workflows, or try out the latest Helm charts from tools like Pulsar, Pachyderm, and Dagster. With simple pricing, fast networking, object storage, and worldwide data centers, you've got everything you need to run a bulletproof data platform. Go to dataengineeringpodcast.com/Linode today, that's LINODE, and get a $100 credit to try out a Kubernetes cluster of your own. And don't forget to thank them for their continued support of this show. Your host is Tobias Macey, and today I'm interviewing Gokul Prabagaren about how he is using Spark for real-world workflows at Capital One and some of the patterns that he's developed to help in his work. So, Gokul, can you start by introducing yourself?
Thanks for, first of all, having me, Tobias, and I'm really excited to share what we have done. And before we, start, I'm Gokul Prabagaren. Currently, I'm an engineering manager at Capital One. My primary responsibility is managing the platform and the application which is responsible for processing customers' credit card transactions and computing the earn for those transactions. In simple terms, like if you have bought coffee or any other things using Capital One credit card, my application is actually responsible for computing the earn for whatever the spend you have done. So it is managed by folks, and I am the one of the engineering manager for the application which does those earn computation.
Do you remember how you first got involved in the area of data management?
Currently with Capital One, it's like the DNA of Capital One's data in it. With the volume what we currently manage, it's compared to that from my old days when I started in my initial phase of the career, I was always associated with data. In my previous role, it was not to the same scale what I'm dealing now. It was for the AT&T backend router provisioning application, and it was pretty much internal to them. But what I was primarily dealing is some sort of ETL process which exposes all the network provisioning orders which have gone through. After a certain time, it was more into the router configuration, and it was all dealing with the data where, say, Juniper router or Cisco router, those configurations, how it all depicted in a logical system compared to the physical real network. That was the thing which I was previously doing. The application which actually has to process those data and figure out the discards between these physical and logical systems. And say when someone is trying to provision, it just validates whether it both are in sync. So I have always been associated with data, but when I really started looking into different way of doing those processes, when I really got into this big data computing, and at the same time is when the things were also progressing on big data or the distributed computing. Apache Spark was coming along. Prior to that, Hadoop we had. So all these things were converging at one point, and that's when I really jumped into this big data ocean. And from then I started doing a lot of things for Capital One. It's all mostly data intensive, and the volume of data we manage, it may not be to the petabyte, terabyte scale. Yes, we do manage those things, but are not on a daily basis. So pretty much I have done a lot of things from my initial days on data. which I continue to do even now in Capital as well.
That brings us to the work that you're doing today. And I'm wondering if you can just start by giving a bit of an overview about some of the types of data that you're dealing with and some of the workflows that you're responsible for in the work that you're doing at Capital One.
So on a very high level, as I was saying, we are a system which is manageable for customer credit card processing. So which pretty much utilizes Apache Spark for most of its processing. And there are some orchestration piece. And if you just take on a very high level 10,000 foot view, it's more like we receive customer credit card transactions and there is a big computation which happens. And then we persist those things. And that's a very high level workflow. And the technology wise, what we deal is mostly Apache Spark, and there are a lot of backend NoSQL database, those kind of things. That's what our workflow is. That's a very high level. The primary business case is computing earn and surfacing that information for customers in different means. And when it comes to the type of data we deal, it's pretty much the specific data format in which we receive. That's somewhat specific. But beyond that, we deal with a lot of JSONs and we persist a lot of information. The enriching or filtering, that also gets into more into the Parquet side of it. Probably those are all high level data types we deal with. And the workflow wise, what we do primarily is get the transaction, compute, persist. That's a very high level blocks is what we deal in, at least in my application currently.
In terms of the kind of volume of data, you mentioned that you're dealing with a lot of Parquet files. So I'm assuming that you're primarily sourcing and depositing information in S3. I'm wondering what you are looking at in terms of the sort of 3 Vs of volume, variety, and velocity as to the magnitude of each of those dimensions and some of the ways that that magnitude might complicate the work that you're doing or add some additional sort of detail-oriented necessity to how you think about approaching those workflows.
So if we get into the 3 Vs part, it's more like the volume wise, it ranges from probably 25 to 50 million daily. And that's what we typically process. That's the volume we process. And when that volume goes through variety of workflows, right? So it ranges from a simple use case where if you're familiar with Capital One cards, the simple case where customer swipes using one of our cashback card, which is Quicksilver, where whatever customer spend, they get 1.5 times of whatever they spend. That is ranging from there to customer getting a specific bonus or their, depending on their portfolio. The variety is, it ranges from various cases, and there is anniversary bonus, those kind of business cases are there. And when it comes to the velocity, it's more like we do have a mix of things, but for this use case, it's more specifically, it happens per day. That's the way we put together things. And that volume is, it ranges from 25 to 50 million. And sometimes it even exceeds that. For our conversation, we can say like 25 to 50 million is the processing volume we actually deal.
And because of the fact that you're doing all this data processing within the boundaries of a banking organization, which is subject to a lot of financial regulations and scrutiny, I'm wondering what are some of the business requirements and regulatory requirements that factor into the types of operations that you're doing, how you need to think about auditability of those workflows, the sort of level of accuracy that's necessary, and some of the ways that you need to verify and validate the accuracy of the computations that you're performing?
So to answer that, we operate in a highly regulated environment, and we need to account for a lot of auditing documents. And we being a source of truth, we have an obligation to produce those documents. And in simple way to put that is, are we always doing what we said we will do? Right? This is like a simple one-liner, but all our decisions has to be viewed in this lens. And the example which we are about to discuss is also a primary reason of implementing that. The enriching pattern was also after fact of this kind of need which arose, because in some case we have to answer what happened. Simple cases, customer can call and then say, hey, why I didn't get this earned for this particular spend? And we are answerable to them. Beyond that, we are answerable to regulators. In a lot of cases, in this scale of volume, we need to see what has happened to that particular transaction. That is one of the simple thing we have. So the lot of designs we actually tackle is also mainly related to those kind of things. And as I said, we process 25 to 50 million transactions, and we need to see what has happened to each one transaction in case if some question arises in various forms, right? And then why that particular transaction hasn't earned. So we are answerable to all these things, and most of our design always accounts for how better we can answer for all this kind of needs. Enriching is one of the things, and there are various SOX related things we do tackle in our whole pipeline. Those are the things which indirectly produces those documents which I was mentioning.
So the data assets that you're producing, I'm wondering who are the downstream consumers, whether it's business end users, if it's other application teams, data scientists, and how do those various consumers influence the way that you think about the format that you need to generate your outputs in?
It's a combination of both, right? We being the source of truth, we are actually responsible for producing the data, which is mainly needed one across the enterprise. So I will group them all as our internal customers. The information what we produce is also used by a lot of our DAs, and they all fall into the internal categories. And there are various, depending on their use cases, all those kind of things. Because of the reason we produce the rich data, there is a need within the enterprise. They all are internal clients. And coming to the external, the simple one is customer get the statements, right? Which is also one of the internal. But similar way, let's take a Costco coupon, right? Which most of people here probably can associate, which goes out every year for the customer, depending on whatever they have earned in the previous year. So if you see that use case, customers are actually getting rewards in that coupon. So we being the system of truth, we are actually we do have similar kind of things in our processing, and we do need to surface that information to our external partners as well. And that actually gets into their systems, and that's how this flow also works. So we do have mix of both. We have internal customers and external customers. Internal being there are various use cases because this data goes into all this kind of warehousing needs and some specific transactional needs. We do have all these use cases internally as well. And externally, I was just trying to give you the Costco coupon example. We do have similar sort of things for external clients as well. So the data we produce is actually utilized by both.
In terms of the technical elements, I'm wondering if you can just talk through some of the system architecture and system design and some of the constraints that you're dealing with as far as how to think about designing the jobs that you're working with and the ways that you're leaning on the tools that are available to you and how you're leaning on the tools that are available to you.
So our data pipeline primarily, as was previously mentioned, uses Apache Spark as its processing framework. And we do have mix of server and serverless options in our pipeline, depending on the use cases. Both are in play. And we use Apache Spark, and there are various ways. If you see, think we do have mix of things. At least the application which I am responsible for, we do have both the use case where batch and real time are being used. But across the enterprise, if you see, we do have batch real time and there are ML related use cases. But when it comes to the constraints, I think over the period we had as things which we have to specifically design for our needs.
You mentioned that you're leaning heavily on Spark, and I know that you wrote a post a little while ago and presented at the Databricks conference to talk about some of the patterns that you started with and evolved to handle some of the specific requirements of your processing workflow and the regulatory capabilities that are necessary to be able to support some of that auditing. But before we get into that, I'm wondering if you can just talk to some of the other ways that Spark is being used throughout Capital One and how you're able to maybe lean on some of the established patterns in the existing infrastructure and data processing kind of aggregate knowledge of the organization.
Across the enterprise, we do have various use cases. We use Spark. Spark being the industry leader in this distributed computing, it is used heavily across our enterprise. Right? For simple batch workload, we consume some file. There are various ETL related jobs, and there are even transactional like ours. There are heavily transactional based processing, which also leverages batch Spark. Some real time based and hybrid way of processing also I have seen, which is more like mix of both batch and real time workloads, solving some real business use case where if customer tips and then they get immediately a notification. This is actually a hybrid implementation across enterprise. There is even some specific ML related things which I am not very close, but I have seen that those are also being used. So we have variety of use cases within Capital One. We use Spark heavily.
In terms of your specific workflow, you mentioned that you're dealing with processing some of the purchase information to calculate what the rewards are that are going to be available to a customer. That as opposed to a fraud situation, I'm sure that there are different requirements in terms of the latency that's acceptable for end-to-end processing. And I'm wondering if there are sort of prioritizations or different Spark clusters that are available to make sure that the fraud analysis doesn't get held up behind the rewards computation or any sort of kind of priority scheduling across the different Spark infrastructure that's available, and how that manifests in terms of what the processing capacity is at any given point.
At least in our world, these two doesn't really immediately collide. In the sense, the case where I was explaining is it's a hybrid case where, let's say, even the fraud is also involved in that. Those actually, it doesn't really get into the hybrid case itself. And we being a transactional processing, it's more on not on a real time is what we actually do. There are mix of those things, but for our use case, we don't really collide with the sharing of resource, those kind of things, because it's not something like a cube where it's heavily shared. Instead, it's more driven by their use case and how they manage the infrastructure. They bring up their compute and then they're done with those kind of things is how it doesn't collide, particularly in this use case where focusing on fraud or computing using customer information or immediately responding to some of the information from their authorization, those kind of things, they all doesn't collide, basically.
And so digging now into the specifics of your workflow and some of the learning that you did in the process of starting with the initial implementation to where you are now, I'm wondering if you can just talk to some of the specific requirements that were in place as far as the information that you needed to be able to compute, the information that was necessary to maintain throughout those various stages of computation, and the initial design that you developed, and what were the priorities that you were focusing on when you landed on that initial structure?
Maybe I'll just dig in more or give a high level mission. What is the use case? And then that will help you can picturize this, right? So the high level use case is, as I said, we process the customer transactions, and there are multiple eligibility things we need to ensure before they really get into the earn computation, right? Something like account eligibility. Simple one is whether this account is really eligible to get rewards, right? And there are various transactional eligibilities, like to say where a balance transfer. That is also one of the things which a customer does. But typically those things customer may not be earning rewards. So just to connect things, that also falls into the transaction eligibility case. And all these things, once we do the eligibility and then see, now the transaction is eligible, they are eligible to get the earn. We do compute the earn on those and then persist in our data stores for various surfacing use cases, right? When it's customer logging into their account through web page or through mobile, to see what are the transactions they had or how much rewards they have, all those kinds of things. Our customer getting the statements which has the rewards information. This is a very high level platform depiction, right? And our initial design actually was using a pattern called filtering pattern in Apache Spark. That filtering pattern uses inner join between simple terms, two different data sets are being joined for a different need. In this example, let's take there is a credit card transaction and we are trying to see out of those, are there any ineligible by based on account or transaction? That's one of this join. And if we use the filtering logic, which was our initial case, to give an example of that filtering, how it was done in the scale, but to just dilute that for a simple explanation, say we had 10 transactions when we started, but when we did the account eligibility out of that, there are only 5 transactions which are actually based on account eligibility. We need to determine the transaction eligibility. When we try to determine the transaction eligibility of those 5, we got only 3 because we are filtering at each stage. So finally, let's say we end up with 2 transactions which are really eligible to compute earn, and then we end up with computing earn for those 2 transactions. This is what I am to explain as filtering, where in each stage of this computation, we filter out the transactions, which means if you take the data set as a row and column, it actually shrinks in rows. When we started with the number of rows as 10, we finally ending up with 2 rows as eligible transaction. So that was actually our initial implementation. And we went live with this, and immediately we realized what was the major shortcoming for that. One, in retrospect, if we have to backtrace any one transaction, right, for those, why it got filtered or which stage it got filtered. For people who are very familiar with Spark, they can say, hey, you can do count at each stage, which is actually a costly operation when it comes to the Spark. We can still do that, but it will only give us how many actually got filtered out at each stage. Instead, if you want to get into the granularity for the regulatory need or traceability need, you need to know not how many which got filtered out. We also need to know why it got filtered out. That with the scale of our operation, say 50 million of transaction processing, we need to figure out, hey, what has happened to that particular transaction? That granularity is what was lacking in the filtering approach. That we immediately found out as a shortcoming, and then we immediately switch over to a pattern which was mostly we were thinking as a enriching pattern. The enriching pattern, the information actually grows column wise. In the sense, when we start with the 10 transaction, the same example, we start with 10. At each stage, instead of filtering out the transactions, we will keep enriching the data set so that there is enough information to make decision. In the same example, let's take 10 transactions. When we try to see how many are really eligible accounts out of this, instead of filtering them out, we will bring in the information and enrich the data set. Same thing for transaction eligibility. Finally, when we try to see who are all not really eligible, using the information we gathered at each stage, number of rows wise, it stays at 10. But number of column wise, it grows because we have been enriching at each stage. So finally, using all the enriched information, we try to make a determination. Okay, we see that these are not eligible accounts and these are not eligible transactions. Finally, end result, we will end up with the same 2 transactions, but how we are reaching to that state is what makes a difference based on their use case, right? There may be some valid use case where people want to compute pretty quickly in memory. Maybe some cases filtering helps. In few cases like ours, where we need back traceability, granular details, for those kind of use cases, Enriching option fits better because at any point of time, you can go back to your parquet information and see, hey, what has happened to that one particular transaction? Oh, this was the reason. At that point of time, this account was actually ineligible to get rewards. That is the reason they haven't got rewards. So that is what actually on a very high level, this two compares against.
Given the fact that you need to persist this information at various stages, I'm wondering if you have looked at leaning on anything such as the Delta Lake format for being able to materialize this information as a set of tables, or any other sort of data warehouse style with, maybe history tables to be able to maintain the different states of computation at those various stages, or if the sort of auditability is only there for sort of regulatory purposes, so you don't necessarily need to keep it live and queryable in a easy to access format, and you just need to be able to maintain that history and perhaps be able to compact it over time.
For this particular use case, we haven't really persisted at each stage. What we have been doing is we have been enriching, so the data set actually grows column wise. So when it comes to the performance, we haven't really seen any major performance degradation, even for the same scale I was explaining, for 50 million transactions, we haven't really seen, because it's a similar data set, whether it's a 25 million or it's only that delta computation where the column is growing, the information stays the same. So persisting really hasn't helped us. But when you brought in this Delta Lake, those kind of things, those things are very recent things which has happened in Spark. So we are definitely evaluating those things. But in our case itself, this is actually a transactional processing. We do push this information for OLAP cases where this information gets out, and there is behind the scenes some sort of use cases where it utilizes this information and takes some reactive actions. That is also is there. But particularly for this transactional use case, we haven't persisted and we haven't seen any major performance degradation. So this is one of the process which is in the transactional pipeline. So we have just kept it as it is because we haven't really seen major performance degradation.
Modern data teams are dealing with a lot of complexity in their data pipelines and analytical code. Monitoring data quality, tracing incidents, and testing changes can be daunting and often takes hours to days or even weeks. By the time errors have made their way into production, it's often too late and the damage is done. Datafold's proactive approach to data quality helps data teams gain visibility and confidence in the quality of their analytical data through data profiling, column-level lineage, and intelligent anomaly detection. Datafold also helps automate regression testing of ETL code with its data diff feature that instantly shows how a change in ETL or BI code affects the produced data, both on a statistical level and down to individual rows and values. Datafold integrates with all major data warehouses, as well as frameworks such as Airflow and dbt, and seamlessly plugs into CI workflows. Visit dataengineeringpodcast.com/Datafold today to book a demo with Datafold. And as far as the kind of performance and storage aspects, as you mentioned with the filtering approach, everything's done in memory, so it's all ephemeral, so you don't have to worry about persisting this information. But because of the fact that you do need to have that audit trail, you want to see what was the data at every point, what were the decisions that were made, and why. You need to be able to persist that information across these various computation stages. And I'm wondering, what are some of the impacts on the overall data volume that are produced by these jobs, going from the filtering approach to the enrichment approach, and some of the ways that latency is impacted as well, and just some of the maybe data quality checks that you've put in to ensure that you don't end up with any sort of regressions as you evolve the job?
There is definitely a delta increment to your whole computation because, as you said, the previous approach, everything was computed in memory, so comparatively that is quick. But when it comes to the enriching option, we are growing the data set at a column level. But what we actually do is we capture a lot of this information, and that information is used to make the determination at one stage. And that is also one of the stage. So that there is only a slight delta increment for your computation. So for this particular use case, we have just seen which is actually a priority for us, right? The delta, can we live with it? compared to the advantages it provides for our use case. So we are just living with that additional delta. But as I was saying, even the 50 million processing, the delta is not too much, right? So the benefit it provides actually overlays that delta processing. So that's what we actually are using, and we are not seeing major latency, those kind of things.
As you have been working on this job and you went from this filtering to the enrichment approach, I'm wondering what are some of the other optimizations or improvements to this workflow that you're planning to build in, or any sort of validation or data quality checking or sort of additional quality control that you're adding in to ensure that you have the auditability, and maybe some of the tooling that you're building to ensure that similar jobs or similar requirements in the future are able to benefit from what you learned in the process of going through this one workflow?
After we realized the benefits of this pattern of enriching the data, we actually have after that, whatever we implemented, we have adopted this pattern as our standard pattern for any of our data pipeline. So the data pipeline we are referring is a bit involved process. There is a lot of sub pipelines, and there are a lot of information and determination done at various stage, and this sub pipeline contributes to the main pipeline. So whatever the initial assessment we did and the implementation, that was on one of the main pipeline, and after that, whatever the sub pipeline we have actually implemented, we have adopted this information across board, and that is also one of the things which we use as a standard. And coming to the optimization or improvements, see, there are various learnings we have heard when it comes to this whole pipeline. And actually, I have recently published one of that as learnings which we had from having NoSQL backends for Spark apps. Right, there are few things which we had to particularly tweak when it comes to having some sort of NoSQL database, where compared to our old traditional data stores which had transaction, all those things are completely, I won't say completely, but the industry is now moving more towards NoSQL, something like a new SQL, all those kind of things. We have made some tweaks, which I have already shared. That topics for another day. But there are some optimization we have actually done in the whole pipeline beyond adoption of this as our standard pattern.
In terms of the work that you're doing with Spark, what are some of the cases where you've run up against some of the limitations there as far as what you're able to do with it, and some of the workarounds that you've built, or some of the times that you've gone to other tools because Spark just wasn't the right fit for the requirements that you had?
One thing which comes to mind immediately is the data types in certain cases in our data set has actually caused some problems for us when we are trying to join some information and do some computation. Certain data types has actually caused some problems like timestamps, because we do manage a lot of this monetary related things, and those kind of things is where I have seen some specific, I won't say it's a limitation, it's not a trivial way to do those things. That is what probably I may say as a limitation we had when we were doing this whole pipeline, but which we have actually overcome by adopting UDFs. In Spark comes this user defined functions, which gives you the flexibility of whatever the specific way your data needs to be processed. You can package them as a particular function, and that function does things however you want. So we have adopted for those kind of use cases as UDFs.
As far as the other ways that you've seen Spark used, or other ways that you've used Spark while at Capital One, or maybe in other jobs as well, what are some of the most interesting or innovative or unexpected ways that you've seen it applied?
We do have various use cases, and we are definitely a Spark heavy shop. There are various use cases we do when it comes to the batch, real time, machine learning. There are a lot of those. One which is closer to me, which I feel like much more interesting, would say innovative, is the combination of both batch and real time for solving a particular business case and giving that customer a real benefit, right? Which is the one I was saying even before, which is like alerting customer when they have tipped high. We think that if we see the same transaction being authorized, we do see if there's similar attributes, and we immediately alert the customer saying, hey, is it the double swipe? Are you really doing second swipe? Those kind of cases where it is actually provided as a functionality to Capital One customers, which in the back end actually does use this hybrid model where some information actually comes from batch computation, and there is definitely a real-time need, which is also done using Spark streaming, where customer gets alerted using the information from both this processing. So that is one which is close to me, and I felt like that is a interesting solution for a customer need.
And in your own work of building on top of Spark and doing data engineering at Capital One, what are some of the most interesting or unexpected or challenging lessons that you've learned in the process?
Challenging, I would say, is when it comes to this whole distributed processing, running a transactional system which leverages Spark as its framework, NoSQL backend, does require a lot of unique customizations and designs to operate in a regulated environment where we are dealing with customers' real money, and managing those things holistically is somewhat challenging when it comes to the operational ways, because Spark is a distributed computation framework, and NoSQL on the other side is also, compared to our traditional data stores, they are also known for scale because the information is also distributed, right? So in some cases, these two goes very well. When it comes to Spark and Cassandra, they're known for processing things at the partition level very well. But when it comes to the Spark and Mongo, how you leverage some information or the libraries which they provide to reap the maximum benefit for a transactional store, it's somewhat challenging, and it requires unique design patterns to have it as a resilient system.
As far as some of the upcoming projects that you're working on at Capital One, what are some of the types of challenges that you're excited to dig into, or some of the additional strategies that you are planning to try out, or lessons that you're looking to learn as you evolve the processing infrastructure of the sort of specific data domain that you're responsible for?
I have been using Spark from very initial days, probably when before it reached version 1. And I have been even following Kubernetes space for some time. So I do see that two of this massive distributed processing, one is a framework platform, converging, right? That with the Spark's latest version, I think around 3.x, they even started natively supporting this. So the convergence of Cube and Spark is one area where I am definitely interested, because moving from VM based processing into container based, using Cube for managing all those things, is something I'm really excited. I want to see all our workloads get into this pattern, because that's where industry is moving. So that convergence actually has a lot of benefits, and we can solve variety of use cases. So that's one thing I'm really curious, the convergence of these two.
Are there any other aspects of the work that you're doing at Capital One and the ways that you're applying Spark to data management for these financial transactions that we didn't discuss yet that you'd like to cover before we close out the show?
I think the main idea is we have followed a particular pattern, and we have switched over to a different pattern for our use case. My goal was to socialize this so that people can make somewhat informed decision for their use case. For some use cases, it may be filtering. Some other use case, it may be enrichment. Right. So those, along with other things, as I was saying, there are a lot of learnings we have had in this whole process, and I have shared in different forms. So those things probably benefits for our audience. Feel like those are the things I actually wanted to cover.
Well, for anybody who wants to get in touch with you or follow along with the work that you're doing, I'll have you add your preferred contact information to the show notes. And as a final question, I'd like to get your perspective on what you see as being the biggest gap in the tooling or technology that's available for data management today.
People can reach out to me in Twitter, and my handle is Gokol, Gokul_P. Or if they prefer LinkedIn, it's Gokul P, one word. So they can reach out to me in Twitter or LinkedIn. Answering the final question, it's more like throughout the process, one thing which I feel like maybe can be enhanced is developer tooling. Because Spark being a distributed computation framework, when we are dealing with a lot of this distributed processing, the developer tooling where they can do a lot of this kind of things on their system. I know Docker does, and we can get all these things onto Docker as well. Little more easier way of handling these things on their systems probably will help developers' productivity. That's one thing probably we can improve upon. Is what the industry I see.
All right. Well, thank you very much for taking the time today to join me and share the work that you've been doing at Capital One and some of the lessons that you've learned as far as the different processing patterns and the benefits and trade-offs that they provide. So I appreciate the time and insight that you've been able to share, and I hope you enjoy the rest of your day.
Thank you, Tobias. It was a pleasure, and thank you for the opportunity. You also have a wonderful day.
Listening. Don't forget to check out our other show, podcast.init, at pythonpodcast.com to learn about the Python language, its community, and the innovative ways it is being used. And visit the site at dataengineeringpodcast.com to subscribe to the show, sign up for the mailing list, and read the show notes. If you've learned something or tried out a project from the show, then tell us about it. Email hosts at dataengineeringpodcast.com with your story. And to help other people find the show, please leave a review on iTunes and tell your friends and coworkers.